So for lesson 86, we're talking about translating the sine and cosine functions. Translating means what again? It's a transformation, but specifically what type of transformation?
Sliding.
Or sliding or moving. So what we're going to do today is we're going to take the sine and cosine functions that we did on Tuesday, and we're simply going to take that graph and we're going to move it throughout the coordinate plane. Let's start with the sine of x. The starting point, did that go through the max and min or the origin? Sine goes through the origin. Very good. And if we had a positive amplitude, it would be something like this. Cosine of x or cosine of theta was when we went through our max or our minimum. So it would look something like that. But once again, today we are moving these things. We are translating them or sliding them, which means we can have a horizontal shift. We can also have a vertical shift. Let's start with the horizontal part. Horizontal shift, that's going to be our h value. And it's the value that occurs on the inside of the parentheses. If we go back to our Spider-Man analogy, Spider-Man can only move horizontally if he's inside the building, correct? Okay, he can get from room 406 to 410. It's when he's on the outside of the building is when he can have that vertical change. Then he can go from floor number 1 all the way up to floor 20. So inside is horizontal, outside the parentheses is vertical. If we look at the inside of the parentheses, that h value, we shift h units, let's start to the right, if that h value would happen to be greater than 0. If we want to go to the left, that would mean our h value was less than 0. Let's take a moment to go back to our vertex form. Because it is very similar in how this works, because with the vertex form, our vertex was the h and the k value, correct? Therefore, if I gave you the example y is equal to negative 2x minus 7 squared plus 5, you would tell me the vertex was what? 7, 5. It's always the opposite on the inside. But the outside number, the vertical shift, that always remains true. If it's positive, it goes up. If it's negative, it goes down. But the inside, it's always the opposite effect. Looks like negative 7, but it's actually positive 7. If it was plus 7, that would be negative 7. It's the exact same concept. If we look at y is equal to the sine of x minus pi over 2. We're going to start with the parent function of sine of x, which is the most basic one for sine. And if we look at that again, sine goes through the origin. It went up to our maximum value, went down to the 0, down to the min, and back to 0 again. In general, this was our most basic. So now when we take a look at something like y is equal to the sine of x minus pi over 2, now we just got to identify, well, what's this pi over 2 doing for us? What type of a translation is it going to be for us? First of all, is it inside or outside? It's inside the parentheses, so we know it's either going to move this thing left or right. So it's a horizontal shift. And which way are we going to move? Left or right? Yes. Shift to the right, pi over 2 units. So when we do this today, typically this was 2 pi, and this was pi. What you're going to do is you're going to take your 5 points that you did on Tuesday, and you're simply going to move them that many units, whichever direction it tells you to. So pi over 2 units to the right. So I need to move this point from here to here. Top point there. This point will go there. This point's there. And that point is there. We didn't change anything about the graph, but we just made a copy of it and we moved it when we need to. Horizontal shift on the inside. Let's talk vertical shift real quick. Vertical shift is when the value is on the outside of the parentheses. So f of x plus k. This is where it stays true. We're going to shift up k units if it's positive or negative. Positive, right? Plus 2, plus 8. So when that k is greater than 0. And then we shift down when it's negative. So the equation that they give us is y is equal to cosine of x minus 1. No parentheses here, right? So understand, if they don't give you the parentheses, the only thing that's considered to be attached to the trig function is just simply the x. So it's minus 1 is on the outside. Hence your vertical shift. Now let's go ahead and establish which way are we shifting this thing, up or down. Down, and how many units? 1. So it's a vertical shift. And we're going to go down 1 unit. Once again, we go back to our most basic function that we have, cosine of x. Remember, that's the max of the min. Which one would it be here? The a value is not there, so it's understood to be a positive one, so it's your max. Down to 0, down to our min. And now we want to create this one off of it. So now we just move every unit down 1. Be careful with your scale. If you're like me, you like to leave spacing in between, so I went with a scale of a half. So if we go down 1 unit, there it is. And that's what you're going to be doing today. You're going to be taking the graph that you created on Tuesday, and you're going to move it either that horizontal shift or vertical shift, possibly both of them. You don't need the entire box, but what I would tell you to do is to write this down, as well as this one. So we are most definitely increasing our, capacity, or we are definitely elaborating on all the different ways that we can graph these. Tuesday we just had the a and b values. Now today we threw in the h and the k values, giving us a total of 4 different values that they're going to give us, potentially. A again stands for the what? Amplitude. B will help us determine the period. This H on the inside is your horizontal shift. K on the outside is your vertical shift. So here it is, example number 3. Maybe one of the more beautiful equations that we could ever get to graph in Algebra 2. Y is equal to 3 cosine of 2x minus pi plus 1. Look at that. Beautiful, right? Just what we were looking for on a Friday. The good news is you go back to Tuesday's lesson and you start with your 4-step process. Step 1, we did what? Found the amplitude. So let's do that. Which was what? It's the absolute value of A, which is 3. Therefore, our amplitude is 3. Easy enough. Let's find the period. Pi over B. What's our B value? 2. There's your A. There's your B. This is your H. That's your K. B value is 2. Therefore, the period is going to be pi. Now, recall, what does it mean to have a period of pi again? Well, that means that's the number of full cycles it'll take, or one full cycle will take place within pi units. Step 3, divide the period into force. What number do we always start with? 0, right? Save that for a little bit. And what do we always finish with? Well, it's our period. Right, Peter? Yep. Uh-huh. 0 and 1 is our coefficient. What's halfway between 0 and 1? 0.5. Yeah, 0.5, or fraction form, half, right? So half pi. What's halfway between 0 and a half? 1/4. So pi over 4, 1/4 pi. And what's halfway between a half and 1? 3 pi force. Or 3/4 pi. Just kind of ignore the pi's. Just establish what your coefficients are. And then if you just think in numbers, it's a lot easier. There's step 3. Step 4 is the pattern to which we're going to take. We got to identify what trig function we're working with first. It is cosine. Therefore, origin or max min? Max min. Which one of the two? It is the maximum because it's a positive A value. If it was negative, it would be the minimum value. So we start at the maximum, and then where do we go? Then we go to 0. Then we go to the min. Then we go to 0. Finish back at the max. Very good. Catch on? And that's coming back to us. Out of all the lessons with Saxon being so random, they actually maybe got it right with this one because they waited a couple of days after lesson 82. So gave you about 3 or 4 days in between, and then they came back to it to review whether or not you know these steps. So our amplitude is 3. And our scale here, well, pi is all the way out to the 4th one, so 1, 2, 3, and 4. And for this one, I'm actually going to shrink it down. I'm not going to skip a unit. You'll see why here in a little bit. But pi and pi over 2. And now let's go ahead and plot our points. We said for the pattern that we start at the max, go to 0, go down to our min, 0, max. There it is. All of this is review, correct? We have not done anything new yet. This is all going back to lesson 82. Now we got to do the new part for today. We need to establish how we're going to move this thing horizontally, if we need to, and then figure out how we're going to move this thing vertically if we need to. Let's start with our horizontal shift. Which way are we going to move this thing? First of all, left or right? Yeah, and maybe before we answer that question, maybe we need to ask ourselves, okay, if I want to determine the horizontal shift, where do I need to look at? Which value is it? Well, it's whatever's on the inside of the parentheses, right? So we're looking at that pi. Now we ask the question, do we go pi units to the right or pi units to the left? We need to go pi units to the right. Again, it's always the opposite. It was minus pi, so therefore we go to the right. Vertical shift. That would be this one. Therefore, up 1 unit. So here's the only new part for today. We established we want to go pi units to the right. We also want to go up 1 unit. So you take the 5 points that you created on Tuesday, and you just move them. So let's start with this one here. Pi units to the right, and let me extend my scale a little bit. That's going to go out to 2 pi. That's actually going to be 3 pi over 2. Pi units to the right, and up 1 unit. Correct? It was up 1. Yeah. Second one, pi units to the right, 1, 2, 3, 4, and up 1. 1, 2, 3, 4, up 1, 1, 2, 3, 4, up 1, 1, 2, 3, 4. When you're done, make sure you have your spacing right. You know, before my spacing was 1 for every one of those, so go back and double check that. Yep, I'm moving over 1 each time. And everything should occur on the same line. These two are on the same. This is midway, that's there. So percentage-wise, for lesson 86, it's not very big, right? That's not a whole lot of red up there. The majority of it all goes back to what you were taught on lesson 82. Questions? Practice problem that I want you to work on? Problem G.